So the good news about number 12. The bad news is I regret putting this in because it talks about baseball, and you kind of have to know how baseball works in order to understand the problem. Okay, base League A allows something, a designated hitter. Okay, so results in League A teams score more. Okay, so let me write that down. There's League A and the other one, League B. So scores more in League A. So this is scores more. And that's really all we need. Okay, blah, 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 League A vs BP, pitcher must bat. So, okay, so in these games, actually, it's expected that League A teams will score fewer. Okay, so regularly scores more. But here in this data set, we think it scores fewer. So this is why I think it's confusing, because you have to know something about baseball. So League A teams will score fewer runs. Okay, then we did this test. So if this is mean A and this is mean B, the alternative hypothesis is that there are fewer runs in League A, mu A less than mu B. So that's what I don't like about this question as much, because you have to read this knowing something about baseball to figure out what the alternative hypothesis is. Okay, so determine the null and alternative. That seems to be choice A right away. The null is always that they're equal, and the alternative is that we expect that League A teams will score fewer runs. Okay, check our answer. Okay, why did it like that? Let's see. Random sample with and without. Okay, so this is, okay. See, this is what I had mixed up too. With DH is supposed to be more. Okay. So we have a with DH and without DH. And this is more. So the null hypothesis actually, or the alternative is actually A is more than B. Okay, so the trick is to look at the with DH. It says with DH should be more. So it actually should be choice D. Oh, it gave me two tries at it. Okay, determine the p-value. Well, now we're just in statistics. Full data set, open in StatCrunch. I think whoever did these problems is a baseball fan. There's another baseball problem next week that I've taken out also. Okay, stat. T statistics, because these are two means. Two sample, because they're independent. They're from all different kinds of games. And this is with data, because we have each individual game. We don't have the average already computed. Okay, why is it greater instead of less? Because League A is with the designated hitter, and it says here, with the designated hitter scores more. So it's a very complicated problem description that's all baseball and not really statistics. Okay, so yeah, it is the National League, American League thing. Okay, so League A park with designated hitter, without designated hitter, and the designated hitter is going to be larger than without. Okay, now I have to do one more thing. What do I have to do? Unclick the pool variances. Exactly. Compute, and the p-value is 0.145. 0.015 to 3 decimals. Okay, so the p is, so with unpooled, so the p is 0.1, what was it, 0.146? 0.146, or rounded to 0.15. Okay, let me just show you what happens if you don't check it. If you leave that in, it should be pretty close, 0.144. This is pooled. And so if StatCrunch was asking for 4 decimals, this would be marked wrong. And it's a relatively detailed math discussion as to which model is more appropriate. Okay, so that's the p-value. So alpha equals 0.05. P is 0.15. Is this a reject or do not reject? It is definitely a reject. P is low. So we reject. The null hypothesis is the same runs, and the alternative was more runs. So we reject. That means we reject the null hypothesis, and we believe the alternative. So reject. There is sufficient evidence to conclude that this results in more runs. Okay, so that's problem 12.